Okay, we're back now. We want to discuss what is heat. Heat is the most randomized form of energy. The universe tends towards a state of entropy. Entropy basically means randomness of motion. That's why it's easier to be in disarray than to be in array, because the universe loves disarray. Of all the forms of energy, heat is the most disarrayed, I could say. It is the most entropic form. So most energy in the universe is in the form of heat. Heat can be defined as the total kinetic motion of particles in an entity. Kinetic motion, you may recall, is energy in motion. Okay? And if I add up all the kinetic motion, let's say, in an entity, that's the heat. Let's take a glass of water. A glass of water, for example, about 200 grams of water, has about 11 moles of water. Each mole, remember, was 6.02 times 10 to the 23rd. So in a glass of water, you have trillions and trillions and trillions of water molecules. They are all moving independent of one another, except for those that are hooked together by hydrogen bonds. Then within the molecule of water, you have the neutrons, electrons, protons all moving. So there's a lot of movement. If I added up all of that kinetic motion, that would be the total heat, shall we say, the total kinetic motion in that particular entity. Now, there's no way of really calculating that for trillions and trillions and trillions, and then you calculate and one changes velocity, so that makes a whole difference. So then, to say it in a loose way, the temperature basically is the average of the kinetic motion, the average. Now, for example, let's take the class. Let's say that we had a class average, where I added up all the grades and averaged them. The average would marginally follow what the total of all the grades are. So on test 2, if many people did better, then the total would be higher, and thus the average will be higher. So the average always follows what the total is. If the total goes up, the average goes up. If the total goes down. So assume that temperature is a measurement tool for heat, because we cannot exactly measure heat. Okay? So you can read that particular slide there. Now, temperature, there are different formulas. There's the Kelvin, there's the centigrade, i.e. the Celsius, Fahrenheit, and be familiar with the different types. So I go further. The relative measurement of heat. Okay, we start first. Now we're using a relative measurement. We start first what we're going to call the heat capacity. Now let's imagine a glass of water again. Okay. If I came in and I was able to measure the kinetic motion of that glass of water, which would be the total heat, or whether I did it by using temperature, which is the average. Okay. Let's say the glass of water is sitting there, and all of a sudden, from the outside, heat is imparted into that glass of water. Heat is imparted into that glass of water from the surroundings. Then the question would come, how much heat needs to be imparted into that glass to increase the motion of particles in that glass, to raise the temperature 1 degree Celsius, also called centigrade. Celsius is an eponym for a name of a person. Centigrade, they call it, because using the centigrade scale, we'll just say it like this. It basically goes, let's say, theoretically from 0 to 100 using water. At 0 centigrade, water freezes. At 100, it goes vapor. It boils. So I'm basing this off of centigrade. So we're saying again that the amount of heat necessary to go into that glass of water from the surroundings to raise the temperature of 1 degree centigrade. Now, likely, for heat capacity, if it was cold around the glass, it would conversely would be the amount of heat necessary to be pulled away from the glass to drop the temperature, because it would be the same amount of energy going up or down. That's heat capacity. Now, let's say that we were looking at it in this fashion, that we had a glass of water and then we had a gallon of water next to it. We're looking at the heat capacity, but we're not quantitating, so we're not really looking at apples versus apples completely using heat capacity, because number one, we're not naming the substance in this, and we're not naming the amount. So we have a gallon versus, let's say, a glass. Specific heat is a little step up above then. The amount of heat that must be gained or lost to change the temperature of 1 gram of a substance. So now that's a better comparison, because now we're saying a gram compared, let's say, so we're comparing two things. A gram of drinking alcohol versus a gram of water. In that scenario, we then can look at a comparison between the heat capability of one versus the other, because we've broken it down into a gram. Equal amounts makes it easier. That's what we call the specific heat. Now we go a step further. A calorie. Now I want you to notice the little c, the lowercase c. The amount of heat necessary to raise the temperature of 1 gram of water 1 degree centigrade. Now we're using water. So what a calorie is, it's a heat unit. It's based on using water as the basis of it. The amount of heat necessary to raise the temperature of 1 gram of water 1 degree centigrade. Now, the average male needs around, let's say, 2,000 to 2,500 calories a day in his diet to keep the same weight. Females generally around 2,000 per day calories. But when you say calorie in that way, you really aren't speaking of this calorie here with the lowercase. You're speaking of the capital C one, known as a kilocalorie, which is the amount of heat necessary to raise the temperature of 1 kilogram, which would be 1,000 grams of water 1 degree. So when you say, how many calories do I burn or how many do I need, technically, even though you're saying the word calorie, it's really kilocalorie. So when you look on your cereal box or whatever, you won't really see the lowercase. You'll see the uppercase. And that's the way they designate a kilocalorie. Now, we go further. So with a new food, how did they determine the amount of calories in that food? Well, there are many different, more modernistic ways, but the old way is to use a bomb calorimeter. You would basically put a gram of food in, spontaneously convert it. You'd have a thermometer in the water. You take the temperature of the water before you started. You then combust the food, 1 gram of it, and see how much this centigrade thermometer raised. However much it raised from what it was before, that basically would say how many calories is in the substance. So again, heat is the most randomized form of energy. Thus, the universe prefers heat. The universe loves entropy, which we'll talk about at another time. And that's, entropy means randomness of motion. So study on that, and thank you very much.